Hello, I'm Paul Hutton, editor of Smart Highways magazine. We're just getting ready to show you another session from JCT Traffic Signals Symposium 2018. But before, let me just remind you of a few things. First of all, if you're at JCT this year or are affiliated to the organisation, you can sign up for a free copy of Smart Highways magazine. Just go to the link at the bottom of the screen. Also, mark your cards for the ITS UK Summit, 26th and 27th of November at the Bristol Harbour Hotel. It will be a fantastic day talking about implementation. And next year, don't forget, Trafex, 2nd to 4th of April. It is the biggest and best Trafex yet. Don't miss it.
Jacky Thomas and Hannah Atkins from DHA Transport. Very sporty, these two. We've got Hannah, who's going to give you a wave so you know which one's Hannah. She's a senior transport planner for DHA. She graduated from the University of Sussex. She did a degree in physical geography, like myself. She joined DHA's graduate programme in 2015. Recently completed a master's in transport planning and management at the University of Westminster. And she's a keen fencer. No gags, just a lull. Then we've got Jacky Thomas. She's a senior transport planner also for DHA. She graduated from Coventry University with a degree in geography and natural hazards. I should have gone into planning, really, shouldn't I? Completed the Highways and Transportation graduate programme with Kent County Council. Joined DHA in 2016 as a graduate transport planner. She plays cricket on a regular basis for Sidcup County Council, and the pair of them make up like a trio of like a dance troupe, an office dance troupe that you've got at the moment with their director who's sitting there, so that they might give a rendition at some point, but maybe not. They're going to come in today to talk a little bit about a different approach in how they quantify mitigation in traffic modelling. So over to you, ladies.
Perfect. All right, thank you, Stuart. Hi, everyone, and thank you for being here today. As you said, I'm Hannah, and this is my colleague Jacky. We work for DHA, which are a planning consultancy based in Kent. And today we're going to talk you through different approaches to quantifying junction modelling and the results of this. So just a little brief introduction to DHA. So it was established in 1986, and it was originally just a planning firm. Since then, we've expanded to employ over 45 people, and it's a multidisciplinary company now. So obviously, you have transport planners like me and Jacky, but you also have urban designers. We also have environmental consultants and flood risk specialists. We work for a variety of different clients, from developers to also the public sector as well, and private landowners. And we also work on a wide range of different sort of projects. We've worked on residential schemes. We've also worked on a number of different leisure centres and also different agricultural schemes too.
So I'm just going to give you a quick overview of what we look at in the transport team. The key aim of our work is to consider the impacts of development on the local network. And we want to try and show that the development accords with national policy and that we're not having a significant unacceptable impact on the network. We produce transport assessments, transport statements, travel plans, and what we look at in there is things such as the sustainability of the site. So we'll look at, is it suitable for pedestrians, cyclists, public transport links? Is there sufficient infrastructure within and around the site for people to be able to access things without relying on a car? We'll look at the design of a site. So is it accessible for all vehicles? Is it permeable? Is it easy for people to walk through? We'll also look at highway safety, so we want to make sure that we're not going to increase any safety issues on the network, and if we are, then we really need to consider how we can mitigate this. And we also look at the traffic impacts on the local network. In doing this, we undertake capacity modelling on local junctions. There are three main types. So we look at priority junctions using a software called Piccadilly, roundabouts using a software called Arcady, and signal junctions using a software called Linsig, which JCT created. So we also look at three key scenarios when we're looking at this. We look at the do-nothing scenario, which assesses the base traffic flows, what's happening at the junction currently. We will grow this to the future years, so when we think the development's going to open, and we will also add in any sort of planned development, so stuff that's going to come forward through the local plan, for example. What we then want to do is look at the trips associated with the proposed development and how this is going to impact the capacity of a junction. So we can do a direct comparison and see if this impact is going to be significant. If we think the impact is going to be significant, then we move on to the next step, which is the do something scenario, where we propose a mitigation scheme. So we change the design of the junction or change the type of the junction. And essentially, we want to try and mitigate any impacts that we're going to have. And if we can, make the situation better. So this is an example of how we would present the outputs of our modelling within the transport assessment. And you'll see that there are 4 sort of key elements to the table. We have the degree of saturation, which is shown as the DOS up there. And this is the ratio of demand to capacity per traffic phase on each arm. We'll generally accept a figure as high as 90%. And once we get to that figure, we think that the junction's operating at practical capacity and we shouldn't really put any more traffic through it. Once the figure reaches 100%, it means that demand and capacity are equal and no more traffic can pass through the arm. We look at practical reserve capacity, which is essentially how much additional traffic can pass through the junction as a whole. We have a look at the MMQ, so the mean maximum queue, how many cars are going to queue on the arms of the junction, and is this going to block back to any of the junctions on the network? And we also look at delay, and this is the aggregate delay to all traffic on the route caused by queuing. So whilst this is a really useful way of presenting the information to a highways officer who has a background in transport, it's not always overly understandable for people without that technical background. And what we find is a lot of the time that members of the public don't fully understand the impacts of a development. And it can mean that they think we're trying to deceive them, trying to pull the wool over their eyes, and it can make them anti-development even more than they already would be. And essentially what we need to do is try and address this. So we've come up with a few ideas, things such as in environmental impact assessments, we know that they have a non-technical summary at the start. So we could try and put one of those into our transport assessment. We can make language a really important feature, make sure that what we're portraying is understandable to people. We need to make it relatable. So if we can say to someone, actually, your journey is going to increase by 2 seconds through this junction, it's a lot more easy for them to understand exactly what those impacts are going to be. And we can also use visual aids. So this, oh, too far. There's a little video that's not playing in the background. So basically, we could use images or videos. This is a video, but it works as an image anyway. And basically, we can show people exactly sort of what's going to happen on the junction. They can see where the queues are going to go back to. They can see that it's generally going to be free flowing, and it can just really help in trying to get them to engage in the planning process and understand what we're trying to show them.
So as well as the things that Jacky has spoken about in terms of language and also visuals, there may be a different way through the use of transport economics. And basically this is defined as the study of the movement of people and goods over space and time. And one of the main elements within this is cost-benefit analysis. So basically, you assess the costs and you also assess the benefits of a scheme and you quantify both. You then develop a benefit-to-cost ratio. And if your benefit-to-cost ratio is positive, it means that your benefits outweigh your costs. And if it's negative, it means that your costs outweigh your benefits, which obviously will have impacts for viability and therefore means that the scheme is unlikely to progress on the basis of the economic viability of it. You can use cost-benefit analysis when you're looking at major highway schemes. So obviously HS2 will have gone through this process, as will Crossrail, to make sure that obviously the costs outweigh, the benefits outweigh the costs. But as part of this, one of the main focuses of cost-benefit analysis is something called transport economic efficiency, which is quantified in terms of travel time savings. And travel time savings is basically the value that a traveller places on saved journey time, which could then be reallocated to other purposes. So it might be more productive time, perhaps you could use it actually at work rather than getting to work, or you may use it for, say, leisure activities, something that you place more highly than just travelling to your destination. So when we're discussing travel time savings, it's quantified in terms of pounds per hour, and there are a number of different elements to this. So for example, there's journey reliability. Say you need to get to work at 8:30 every single day, but you know that sometimes your route isn't particularly reliable and there's congestion on it. So you're going to inbuild some flexibility, say 10 minutes, just so that you know that you'll get there on time. Whereas if you didn't have this issue, you would leave at 8 o'clock every day and you'd know that you'd get there. So obviously, it's quite nice to have a more reliable journey. You also have the issue of quality of journey. Again, if you're sat in congestion, that's not particularly pleasant. So if that wasn't there, then your journey quality would be much better. And then also it looks at the different type of journey that you're undertaking. So are you commuting, or are you going for business, or perhaps are you going for leisure? So if you're looking at business, this is quantified more highly because it has direct economic benefits. Whereas if you're going for leisure or say commuting, it's quantified less simply because the benefits are more indirect. There are sort of a number of limitations to the sort of the way that cost-benefit analysis is run at the moment. Obviously, travel time savings focuses a lot on business journeys. As I've said, they're quantified more highly by comparison of leisure or commuting trips, but actually that may not be reflective of how you value your time personally. You also got the issue of willingness to pay bias. So obviously this is done on the basis of what you would be willing to pay to save that time. So it's a subjective term and different people will quantify it differently. You also have the issue that, say, if you ask a slightly more affluent person what they would be willing to pay, it may be financially more than somebody who is less well off. But that doesn't mean that they're actually quantifying it any differently. It's just the basis of how much money they have to spend. Then you also have the fact that actually cost-benefit analysis, about 80% of it relies on travel time savings. So that 20% is left for sort of considerations of social and environmental issues. So for example, social, you could look at severance, which is where if you put a road through a town, how will that impact the social activities that go on within that town? And then you also have environmental, such as air quality and pollution. Obviously, only 20% of that is looked at within cost-benefit analysis, and a lot of people think that should be more highly regarded as it's kind of an increasingly prevalent issue.
So we're just going to talk you quickly through a case study where we've looked at travel time savings and how we can use this to portray the impacts of a mitigation scheme. So this is a 4-arm signal junction just to the south of Maidstone. It's the Linton Crossroads. And as you can see from the image, it already suffers from quite significant queuing, particularly in the PM peak. So we were working on development proposals to the southwest of this site, which had the potential to increase the number of vehicles routing through this junction. So we wanted to assess the impact and see if we could mitigate that. So Maidstone Borough Council already acknowledged that there was an issue and had designed a scheme, and through additional land provided by our client, which is that highlighted in red there, we were able to enhance this scheme. In essence, the scheme involved adding extra lanes to the northbound and southbound approach, so we've now got 3 lanes on each of those arms. We realigned the curbs, realigned the lanes to make routing through the junction easier, particularly for larger vehicles. We provided a bus lay-by on the western arm to allow loading and unloading to take place off the carriageway, so we're stopping vehicles blocking back into the junction. And we also provided some enhanced crossing facilities through the provision of a controlled pedestrian crossing on the eastern arm.
So we then took a look at the modelling for this, and the top table is the de minimum scenario, so that's as existing. And as you can see, it's operating significantly over its design capacity. We then took a look at it in terms of the do something scenario, which is where we've added the mitigation. And as you can see, there are clearly noticeable benefits as a result of the mitigation scheme, especially when you're looking at the likes of the delay and the overall degree of saturation on each of the different arms. Obviously, whilst theoretically the junction could operate over capacity like this, the reality is that a lot of people will likely reroute if they know that it's going to be a pinch point on their journey or it's going to be particularly unreliable. So you obviously need to take the results of this in the context of people rerouting and changing their journeys and also their travel times. So I wanted to see if there would be a different way of quantifying this rather than just putting those tables into the transport assessment. So what I did is I used the Department for Transport's Transport Analysis Guidance, User and Provider Impacts. This is basically a document that helps you to take a look at cost-benefit analysis and how it can be quantified. I needed to know the delay that the vehicles were experiencing through the junction. So obviously in the table before, we looked at the aggregate delay for the junction. I actually took the seconds per PCU for each of the different movements, as I needed to know sort of the per vehicle delay that we were experiencing. Once I'd sort of worked out where I was going to get delay from, I needed to understand what different types of journey purposes were being made. And that's where the top table comes in. And it basically shows you the proportions of work, commuting, and other trips that are taking place during the peak periods. So from this, I was able to get a percentage split and apply it to the different vehicles going through the junctions. What I then did was, for ease of assessment, I considered all of the vehicles to be cars. There was only quite a small percentage of HGVs and buses going through the junction anyway, but actually if you assume that they're all cars, it's a more robust assessment in terms of the economics, as HGVs and buses tend to have a higher work-related purpose, which means that overall they have a higher economic value. So if you're looking at the cars, then you sort of get a more robust assessment. So then I needed to assign the monetary value to the different journey purposes, which is what the second table is here. As you can see, work-based trips are valued higher than commuting and other, which would be sort of education or leisure. So what I then did is I knew the amount of vehicles, I also knew the delay that they were experiencing, I knew the proportion of work and non-work-based trips, and I knew the value that was assigned to them. I also converted from pounds per hour to seconds, just to make it easier when you're trying to factor it against everything, to then basically get the overall travel time savings that you would experience. To do that, I also made it a per annum. So basically what I did was I factored my figure against 253 to remove weekends and bank holidays from consideration, because really we're only interested in the weekday AM and PM peaks. As a result of this, across the year, you'd have travel time savings of about 1.5 million as a result of the mitigation scheme. So that's quite a significant enhancement. And actually, it's a more universal way of communicating things rather than if you're talking in PCR or PRC, then it's not always the easiest thing to understand. But if you're looking at it in economics, then people can take a look at that and go, oh, I understand that. That's a net benefit of 1.5 million. It's much more easier to convey to different stakeholders.
So just to summarise what we've learned through this process, I mean, we've really identified that communicating the impacts of development to all stakeholders is really important, especially if we're trying to get people engaged and give us some constructive feedback and be able to understand how development is going to impact them. There's some simple ways we can do this, so we can provide non-technical summaries, we can change the way we speak to people, so using language that they understand and also using relatable terminology, and we can use visual aids to try and further enhance how people can see what we're trying to show them. And this kind of additional information would be quite simple to do for smaller scale schemes, or when we're looking at existing junctions and simply trying to demonstrate that the proposals aren't going to have a significant impact.
But when we're possibly looking at the ideas of mitigation, then maybe there's a role for transport economics. Obviously, as I said, the likes of HS2 and Crossrail have fully in-depth cost-benefit analysis undertaken for them. And I think in the main, the majority of schemes we work on probably don't require that level of depth. But it's quite interesting that you can create something using transport economics that could be communicated to different people and different stakeholders. As I said, we've just kind of scratched the surface here of what transport economics can do, and in some instances it is likely to be too much detail for some people. But if we can communicate if we can improve the way we communicate to stakeholders, we can help them engage better with the planning process, which is ultimately what we're trying to do. And at the moment, we think something does need to change if we are to get everybody involved and to get everybody to understand sort of the transport elements of development and planning. So yeah, thank you for listening, and if you've got any questions.
No doubt there'll be a few questions. Thank you very much there, ladies. Mark, your hand's up straight away.
You said at the outset that your objective was to communicate more effectively to an audience that were not necessarily experts in the field. Have you undertaken any, let's call it market research for stakeholders to find out whether that is actually the outcome that you are achieving, or when you plan to?
I mean, we haven't really progressed this beyond this room, really. I undertook the transport assessment or the economic assessment a little while ago, and it was just something I'd learned actually through university, and my director wanted to see if we could maybe get it to work. But we have been recently discussing it in the office that increasingly we find that people aren't necessarily understanding what we're doing. So we would like to start putting it out there. I definitely think it's something we'd like to start trialing in some of our transport assessments, just to see if it does improve the way that things do it. And obviously, as we go to public consultation events, it might be something we could discuss with the public and say, look, we do this now, but obviously this may not be working. Do you have any other ways that you would like this to be communicated? So,
it would be good to know.
Yeah, I was about to say, it's in its infancy, but yeah, we'd be very, very keen to understand if it's something that could be progressed.
Thank you.
No.
Question, is it Dan? Yeah.
Dan Priest, Integrated Traffic Services Limited. I think on the case study you've just done, obviously there's quite close collaboration with the local authority and presumably their signals team on that.
Yeah.
One thing I come across doing work, maybe been through the transport planning stage and the modelling, is that often there's some assumptions that have been made, and maybe the traffic engineering side of it is either simplistic or wildly unrealistic. And some of the work I've started doing with a couple of companies is to become involved at the transport planning stage as a traffic engineer. I'm just wondering whether as part of this, you're looking to engage traffic engineers at the start to kind of make sure that as transport planners you're using best current thinking to maybe solve some of the problems and increase mitigation.
So we don't actually undertake signal modelling ourselves. We do use JCT to do that, and we try and get them involved as early as possible when we're designing schemes, not just when we're assessing them. And we do also have engineers in-house in terms of the actual design of junctions as well. So yeah, we try really hard to sort of get that done at the start rather than get halfway down the line and find out that actually what we're proposing doesn't work at all.
Okay, I suppose you could say that JCT was signal experts.
Maybe a little bit.
Maybe. just a smidge.
Yep, Tim.
Helen Kanzik, Transport for London. Have you applied any similar economic analysis to things like improvements in road safety or environmental improvements? You alluded to it, but this was very much based on travel.
Yeah, it is very much based on travel, and it's something that I'm hoping to progress. Obviously, I'm not really... My background isn't transport economics, so it's something I'm learning and kind of picking up as I go along. So this was kind of my first attempt, and it was something that I just wanted to discuss with people. But I'm hoping to, I know there's like cost-benefit analysis that you can get from the DFT, and I'm hoping that we could progress with that and I can start to understand in more detail the environmental and the social impacts of different schemes and how I could quantify those, because obviously they're ever so slightly more subjective, and I think that's possibly the issue. But there obviously are ways of doing it. I haven't quite come to those yet, but I'm definitely going to start looking into them and try and investigate them to bring them forward.
Thank you.
I thought I saw a hand at the top twitch, but did it? Yeah, okay.
Wasn't so much a question actually as a sort of an item of feedback, picking up on the very first question that was asked around communication to the public. And I thought you might find it interesting actually if you, because obviously you started with some high-level aggregated results across the whole junction, so you've got the maximum queue, the saturation, etc. And you've gone back down to actually looking at individual user delay by journey purpose, but you've ended up back at the top again with this aggregated number. And I just think if you do go out and speak to the public about this, it might be beneficial if you take a few steps back in your work and actually present to the users the delay figures. Because I think in the same way that you'll lose people if you start talking about degrees of saturation, if you start saying, yeah, you're a commuter and your time's worth £7.60 per hour, you'll probably lose them at that stage, whereas if you say, okay, with this redesigned junction, you would expect on a typical Tuesday morning to be stationary here for 30 seconds, then it's rather more accessible. Yeah, I've used WebTag as well, and the deeper you delve into WebTag,
Oh yeah.
from the further reality you get, the journey time reliability bit is particularly horrendous.
Oh yeah, no, definitely. You can definitely get lost in the many documents.
Not a question, so apologies, but more of a discussion point.
No, but it's really good because we are starting to quantify it more in terms of delay recently, because again, we are finding degrees of saturation and things are just a little bit alien. But it's just nice to try and see if you can do it in different ways and to get feedback about those different ways, really.
Two more questions, Chris? Yeah.
Hi, you're claiming quite substantial benefits here. Where do the multipliers come from to give you those numbers?
They're all through WebTag guidance. It's all through the DFT's different. They've got a number of different reports that they've generated on cost-benefit analysis. So if you basically Google WebTag guidance in terms of economic appraisal, there's a number of different documents that come up, and they've got different tables, which is the ones that I had up on the screen, and they basically guide you through it. They also have software, I think it's called Tuba, which is actual dedicated cost-benefit analysis software, and you can input different things, including like road safety, environmental and social impacts. So you just basically follow their guidance, and that's where all of this information came from.
Thanks.
And the last question then from Chris.
Thank you. Chris Kennett again from Green Signals. It's probably a wider point rather than this, but if we use the cost-benefit analysis at this kind of level, and I know in some places it's already done, is there a potential that we end up just investing in areas that are already wealthy and have high numbers of well-employed people, by which I mean high-value jobs, and actually taking money away from places where, if we invested in some of the deprived and rural areas, we could actually gain more employment?
Yeah, that's one of the points I raised, which is the willingness to pay bias. Obviously, if you are more affluent, then you will pay more, but that doesn't mean that you value it higher than somebody who is less affluent. So you do have to be very, very careful, and it is one of the challenges with cost-benefit analysis, which I think they're still trying to iron out at the current time. But obviously, hopefully if you're working with councils, they will understand where they have the different demographics. So hopefully you would assume that obviously, like for example in Kent, we have different towns, like Tunbridge Wells is more affluent if you compare it to Maidstone. You'd hope that the councils understood where the pockets lie, and hopefully in the future you might be able to get somehow different multiplier factors to account for this bias and maybe to bring it in line. But yeah, it's a very important point, and it must definitely be considered.
Because at the moment it doesn't necessarily come out in that last value.
No, it doesn't. So you do. It's one of those things that I'm hoping. There's a few things obviously with transport economics that do need to be ironed out, and I'm hoping that that's one of the things that they'll start to look at in more detail.
Thank you.
It's okay.
Fantastic, excellent audience participation. I'm really pleased with that lesson. I mean, that session, it went quite well, didn't it? And it means I don't have to fill any time talking about Oxbow Lakes or anything. So I'll hand it back to John, and he'll obviously give you the information on where you're going to go next. But big round of applause to Martin, Nick, Hannah and Jacky.